Okay, today we're going to talk about most of our time is going to be spent with the unit circle. But the first thing we're going to talk about is another way of measuring angles. And you guys are all very good at measuring angles in degrees, but we're going to use something that's called radians. The only difference is about radians is that it actually measures arc length. And so when we talk about arc length, we're actually talking about partial distance around a circle. And when you think about distance around the circle, what do you think about? Circumference. Okay? So we're basically talking about the circumference of the circle and just doing pieces of it. Okay? And certain lengths of circumference. Well, 1 radian is, it's shown here as what the approximate is. It's 1 radian is actually about 57 degrees. And the thing is, when we're talking about distance around the circle and we talk about circumference, there's a formula for that, right? What's the formula for circumference of a circle? Pi r squared is the area of a circle. Okay. Okay. What's the circumference of a circle? 2 pi r. Okay. And 2 pi r is very important, the circumference, because we're going to talk about the distance around a circle is how we're going to work with a lot of things we're dealing with. Okay? Now, first of all, we know that all the way around the circle is 360 degrees. Okay? But in radians, it's 2 pi, because we assume for that the radius of our circle is 1. So when we're talking about radians going around the circle, it's 2 pi radians. And so halfway around the circle is 180 degrees, or pi radians. And so the first thing we're going to do is we're going to look at converting from angles from degrees to radians and radians to degrees. So we're going to use these two conversions to do it, which you've done lots of conversions. You've converted from feet to miles, feet to inches, centimeters to meters, all right? Ounces to pounds, okay? You've done lots of conversions, and we're going to convert from degrees to radians and radians to degrees. And a lot of this with these conversions is we're just going to take fractions and simplify them. So first of all, we're going to change from degrees to radians. So I have negative 60 degrees here, and they want me to convert it to radians. So I'm going to multiply by pi radians over 180 degrees. So negative 60 times pi over 180 degrees. Now, when you're checking to make sure you're using the right conversion, the thing is always remember that I want to cancel what I start with. Okay? So in other words, I have degrees here, and so I want degrees in the denominator so that they could cancel. Right? If I had radians, then I would want radians in the denominator to cancel. So what I'm going to do is I'm going to write this as a fraction and then just simplify it. So this would be negative 60 pi over 180. And then what do I get when I simplify 60 over 180? Okay. All right, 1/3, because 60 goes in 180 3 times. So this would be negative 1/3 pi, but we're not going to write it that way. Okay? We're actually going to write it so that it says negative pi over 3. All right, so we won't write it as 1/3 or 2/3 or whatever. We'll put it at, say, it's negative pi over 3. And we're always going to leave pi there. You're not going to use 3.14 and try to find a decimal number. Always going to be a simplified fraction. Letter B, they give us 2 pi over 3 radians. And they want us to convert that to degrees. So we will multiply this then, 2 pi over 3 times 180 over pi. Since I have radians here in the numerator, pi in the numerator, I want pi in the denominator. so that they will cancel. So these pi's cancel. Then it's just a matter of simplifying 2/3 times 180. So what's 2/3 of 180? You can multiply. Okay, 2 times 180 is what? Okay, it would be 120. Okay. 2 times 180 is 360, and 360 divided by 3 is 120 degrees. Okay. Now, one thing is that when you are writing an answer in radians, you don't have to write radians or put anything there. It's understood that that is radians, but whenever it's degrees, you have to put the degree symbol there. Okay? So make sure you remember to do that. Okay. All right, now we are going to learn about the unit circle. Now, this part of this, and I don't see anybody's book open to it right now. If your book is open to it, please turn the page, because I don't want you looking at it while we do this, because I want you to really focus on what I'm telling you, and because when we're all done with this, you see there's a lot of blanks there, but there's also other things going to be added to that. You are going to have this memorized, and you will have to fill out a blank sheet like this for me on Friday. Okay? So 40 points on a quiz. So on Friday we have a quiz, and part of that quiz is going to be the memorization of the unit circle. Okay? It's the largest point quiz that I give. So, okay, unit circle. The reason this is called the unit circle is because the radius of the circle is 1. Okay? Makes it easiest that way. And what we're going to do is we're going to put on here degrees, radians, and sine, cosine, and tangent. Okay? Now, one of the things you might want to have on eventually, and you can do this, don't do it right now, but later, is you might want to put down either on the back, one of the corners maybe, put the 2 triangles, because we will be using them in filling this out. Okay? Now, first of all, we're going to talk about degrees. Okay? And our angles are going to be inside the circle, okay? And then we're going to have coordinates on the outside of the circle. So first of all, the easiest one for degrees is 0, right? Okay. Now, if I go all the way around the circle in degrees, what is it? 360, okay? So this spot here is the same, 0 degrees, 360 degrees. Okay. Now, when I fill this out with degrees and radians, it's a matter of being able to count. If you can count, then you can fill out the inside part of this with degrees and radians. Okay? Because it's just a matter of using little counting techniques and a little bit of work with fractions. And the fractions is just a matter of counting and simplifying. Okay? So halfway around the circle is how far? 180. Okay, so over here then, on the negative x-axis, I'll have 180 degrees. And halfway from 0, we're going to be breaking this circle up into pieces, and that's why if you notice that there are thinner lines in places and thicker lines in places, just to help you to recognize some of the differences. But if I go halfway around, or if I just go to halfway on the top, what is it? 90 degrees. Okay? So we could start here for a moment, and we can actually count by 90s. Okay? 0, 90 to get to the positive y-axis, 180 negative x-axis, and then what's it going to be down here at the negative y-axis? 270. Okay? So all I did is just add by 90s, and I get then the 360. Okay? Pretty easy. Now, if you look at the top half of the graph, okay, of our unit circle, and pay attention to the thin lines, okay? I've taken this unit circle here, and it's divided into 1, 2, 3, 4, 5, 6 pieces. Okay, can you see that? All right. The thin line here, one piece, thin line to thin line, then to the 90, to thin lines, okay, and 0. So there's 6 pieces there. If I take 180 degrees and if I divide it into 6 equal pieces, how much is each one? 30, okay? So this first one here is 30 degrees, and all I'm going to do then is count by 30s. How many of you can count by 30s? Okay, I hope all of us. Okay, so we're going to count by 30. So we have 30, the next thin line is 60, then 90, 120 to the next thin line, 150, 180, and so on. Now make sure that you're writing these towards the inside. All right? Because we're going to be putting radians in there also. So you're going to need room around the outer part of the inside of the circle. Okay? So there's our going by 30s. Now if you notice, there are thicker lines, right? Okay. Well, those thicker lines do what? What do the thicker ones do? Okay. They cut each quadrant, okay, in half, right? Or you can think of it this way. I've taken the top half of the circle, which is 180 degrees, and I've broken it into 4 parts. And if I divide by 4, 180 divided by 4 is what? Or what's 90 divided by 2? Okay, 45. Okay. So all the dark lines then are going to be multiples of 45. We're going to add by 45. So we have 45 here between 30 and 60. And if I add 45, I'd be at 90. Add 45 and at 135 degrees. Add 45 and I'd be at 180. Then 225, 270, 315, and 360. Okay. So there's our degrees. Okay. Not too easy, a little bit of counting by 30s and counting by 45s. All right, we can do that. All right. Now let's talk about the radians. Okay, with radians, how far is it around the circle? Okay, in radians, how far is it around the circle? 360 degrees is the same as 2 pi radians. So where we have 360, that's also 2 pi when we're talking about radians. So then halfway around the circle would be 1 pi, or just pi. So just like we took 180 degrees and divided into 6 parts, we got 30 degrees. What happens when I divide pi into 6 pieces? What do I get? Okay, or if I take 1 and divide it by 6, what do I get? 1/6, right? Okay, 1 divided by 6 is 1/6. Okay. So if I had an actual pi, circle, whatever, and I took that circle and I divided into 6 pieces, 6 even pieces, then you would say, and I gave you a piece, you'd say you had 1/6 of the pi, right? Okay. So then each one of those pieces then is 1/6, so this is pi over 6, or 1/6 pi. And so just like we counted by 30s, we're going to count by 6. Okay? So after 1/6, I have 2/6. Okay, so at 60 degrees, I have 2/6, but 2/6 is the same as what? 1/3. So at 60 degrees, I have pi over 3. Then at 90 degrees then, so I have 1/6, 2/6, and then what comes after 2/6? 3/6, which is 1/2. So this is pi over 2. Okay, that's the same as 3 over 6. Then I would have 4 over 6, which is 2/3. So this is 2 pi over 3 at 120 degrees. And that was one we did in our example when we were doing conversions. After 4/6 comes 5/6. So 5 pi over 6. So all I'm doing here is adding by 1/6, 2/6, 3/6, 4/6, and then just simplifying the fractions. So then we have 6 over 6 for pi. Then 7/6, so 7 pi over 6. Then 8, which is 4/3. Then 9, and 9 over 6 is what? 3 over 2, yeah. 3 pi over 2. Then 10/6, which is 5/3. And then 11/6. And we could go to 12/6 would be at 2 pi. And then we could even keep counting. 13/6, 14/6, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, and just keep going. And we could also do it in the negative. -1, -2, -3, -4, -5, just like we could do negative degrees, because yesterday you did that, right? You drew negative angles, and it always went to the right, then, or to clockwise. You could count with radians clockwise, or angles. Now, the other ones here then for radians, we've taken the top half of the circle and we've divided into 4 pieces. So if I take pi and I divide it by 4, what do I get? Pi over 4. So we're at 45 degrees, I have pi over 4. So then now we're going to count by fourths. So we have 1/4. 2/4 is 1/2. We already have that at 90 degrees. Then over here would be 3/4, or 3 pi over 4. Then 4 pi over 4. 5 pi over 4. 6 pi over 4 is 3 pi over 2. And then 7 pi over 4. And there's the radians and degrees on the unit circle. Now, around the circle are coordinates. Those are exact measurements. Okay? And so here we have a point here. Like I said, this is a unit circle. Reason it's called a unit circle because the radius is 1. And if the radius is 1, what's the coordinate of that point there? Okay, 1, 0. Okay? This is the point 1, 0. Because I'm going out horizontally, I'm going to the right 1, and I'm going up 0. So look at pi over 2 on the y-axis. What's the coordinate of that point? What's the coordinate for this point right here? 0, 1. X is 0, y is 1. Now make sure you're putting this in the coordinates, okay? Inside the parentheses. All right? The outside of the parentheses is going to be for tangent. Over here at pi, what's the coordinate of that point? Okay, -1, 0. We went to the left, -1, went up or down 0. What's that? Nope. Just like your quiz today. And then we have 0, -1 for 3 pi over 2. Everything else from lessons 1 through 4. Okay. Okay, so there's the outside. Those are the axes. All right, easiest ones are the axes. Now, one of the things is that all of our points here are going to be cosine, sine, and then tangent. Okay. Cosine and sine are the coordinates of the points. Tangent is on the outside. Because if you remember with what we were doing yesterday, that this says that sine is y over r. Cosine was x over r. Tangent, y over x. Well, if r is 1, okay, so think about it. If r is 1, then sine is just y. And cosine would just be x. And so when we're using the unit circle, cosine is always refers to x. Sine always refers to y. So here we have this 30-degree angle. And if you notice with this 30-degree angle, I actually have, you can look at this as a right triangle. Oh, this is a 30, 60, 90 right triangle here. So in my 30, 60, 90 right triangle, what is the cosine of 30 degrees? What's the cosine of 30 degrees? Square root of 3 over 2. Adjacent over hypotenuse. Cosine is square root of 3 over 2. Okay. What's the sine of 30? Sine is opposite over hypotenuse, so sine would be 1/2. So here I have square root of 3 over 2 and 1/2 for my coordinates of that point. And those are the actual true values of the coordinates of that point right there. Okay. If I had my grid on there, I could see it exactly there. Okay. Now let's look at 60 degrees then. We're going to skip 45 for a moment, go to 60. How does 30 and 60, how do they compare? If here's my 30-degree angle and I got square root of 3 over 2 and 1/2, what happens if I have the 60-degree angle? What happens to them? Okay, they switch. So at 60 degrees, we have 1/2 square root of 3 over 2. Okay. How about 45? Some very colorful water. Okay. All right. Square root of 2 over 2. 45, cosine 1 over the square root of 2, sine 1 over the square root of 2. Okay. So we know we can't use 1 over the square root of 2. We actually have to change that. So at 45, it's square root of 2 over 2. Now, all the other 3 quadrants, okay, are just reflections from there, or use of reference angles. Right? We're going to stay with sine, cosine, and tangent, or just say cosine and sine right at the moment. We'll do tangent last. But for everything else that goes with them around the circle, it's just a matter of doing reflections. And when I do reflections, the only thing that changes is what? Okay, the signs, whether they're positive or negative. Okay. So in the first quadrant, we know that x is positive and y is positive, correct? When I move over to the second quadrant, what's x and y? Okay, we move to the left, so x is negative. We go up, so y is positive. Go to the third quadrant. What are x and y down here? Okay, they're both negative. Right, because I'm going left, which means x is negative. I'm going down, which means y is negative. Right. And in the fourth quadrant, we went to the right, so x is positive. Go down, so y is negative. Right. So when we do our reflections, these signs all matter. Okay. So we talked about reference angles, right? And I drew this nice, lovely chart down here that looks kind of funny. Okay. But this all applies to what we're going to be doing because the coordinates are going to be the same except for change in signs. You really might want to pay more attention to this than your notes you want to communicate to each other. You can do that during practice. Okay. So when we look at 30-degree angle here, if we take this and we reflect it over here, okay, so take this and reflect it over here, then these numbers are all going to stay the same except x is going to be negative and y is going to be positive. So we have negative 1/2 positive square root of 3 over 2. Negative square root of 2 over 2 and positive square root of 2 over 2. Negative square root of 3 over 2, positive 1/2. And here's the thing, okay? Remember, like I said, these are coordinates of actual points. So that means then my y value here should be the same as my y value over here. Okay? Positive 1/2, positive 1/2. Okay? My x value here should be the same as this x value here for that triangle. So you have to remember that. Now, the biggest mistake that's made on this unit circle, okay, for the people, if you know it, the biggest mistake is made coming down here to the third quadrant. Okay? Because what happens down here is everybody wants to take these numbers and just slide them down just like they are. Okay? But it's a reflection. So when I reflect down here, that means then that the ones farther away from the x-axis are still going to be farther away from the x-axis. Okay? Also think of it this way, all right? Here I have my reference angles of 30 degrees. So at 150 has a reference angle of 30 degrees. So these coordinates have to be the same. I went the same distance horizontally and the same distance vertically as I did here. Same thing happens here, all right? And I'm going to give you another little tip of how that works too, but same thing happens here. This is a 30-degree reference angle. That means then whatever my 30-degree angle is here, I have to use those same numbers. It's just that in the third quadrant, they're both negative. All right. Just like we used pi over 4 or 45 degrees is this middle one. I'm still using those, square root of 2 over 2 and square root of 2 over 2. Negative 1/2, negative square root of 3 over 2. And there's another way to remember them also, okay? Think of it like this. If there's a 6 in the denominator, okay, they have the same coordinate. The only difference is the signs. Okay? 6 in the denominator, square root of 3 over 2, 1/2. 6 in the denominator, square root of 3 over 2, 1/2. 6 in the denominator, square root of 3 over 2, 1/2. Okay? And the same thing over here. The only thing that changes is the signs of them, positive and negative. Okay? So there's sine and cosine. So we got degrees, radians, sine and cosine. The last thing we need to work with is tangent. Now, we talked about this here, that sine is y, cosine of x. Well, what's tangent is y over x. So at 0 degrees, if I take, to find tangent, tangent's on the outside, I go 0 divided by 1, what do I get? What's 0 divided by 1? 0. Okay. 0 divided by anything is 0. How about here at pi over 2? Y divided by x. What's 1 divided by 0? Can we divide by 0? No, you cannot divide by 0. This is undefined. U-N-D, undefined. Okay. At pi, 0 divided by negative 1, 0. Three pi over 2, negative 1 divided by 0, undefined, because you can't divide by 0. All right, for the other angles then, 30, 45, and 60, I look at my two triangles. Okay. What's the tangent of 30 degrees? Square root of 3 over 3, Cody says. You guys agree? Okay, so it's 1 over the square root of 3, tangent 30, 1 over the square root of 3, but we don't leave it that way. So it is square root of 3 over 3. At 45, we get 1 over 1, which is 1. And at 60, square root of 3 over 1, which is the square root of 3. Now, when we did these signs here in green, our part in green here, all right, so we did x and y, so then y over x is positive in the first quadrant, right? If I go to the second quadrant, I have a positive divided by a negative is negative. So tangent will be negative in the second quadrant. Third quadrant, if I have a negative divided by a negative, it is a positive. Okay, and so I'm writing them the order I have them written on my unit circle. Fourth quadrant, negative again. Okay. Negative divided by positive is negative. So with tangent, we're just doing reflections also. It's just a matter of what the sign is going to be. So in the second quadrant, the sign of tangent is negative, square root of 3, negative 1, negative square root of 3 over 3. And they stay together. Third quadrant, negative positive square root of 3 over 3. All right, because the negative tangent is positive in the third quadrant. Positive 1, positive square root of 3. Fourth quadrant, negative square root of 3, negative 1, negative square root of 3 over 3. And there's your unit circle. So that's what you have to memorize right there. Okay. With the degrees and radians, what did we do? We worked with parts, right? Okay. 30, 60, 90, 45, 90, so on. But if you look at the degrees, the one in the middle is always what? Okay? Between the other two, 15 degrees either way. Radians. Okay? We use fractions and just added. Okay? With the coordinates, if you can memorize the first quadrant, okay, then everything else from there is just reflections, making sure you have the right sign of positive or negative. And you can do all those if you know the right triangles also, because everything can be done from the right triangles, the 30, 60, 90, and 45, 45, 90. Okay. All right, so now we're going to use it. All right. So when you come in here for the next week or so, you're going to want to make sure when you pull out your homework, open your book, first thing you want to pull out is that unit circle, because you're going to be using it. All right. You're actually, I'm going to give you a little quiz on it tomorrow, just the use of it, okay, which is pretty easy. All right, so this is what they show in the book. All right, real nice. The only thing is it doesn't have tangent, so you have tangent besides that. So let's use it here. So they want us to use the unit circle to find the exact value of each trigonometric function. Cosine of 225. So find 225 degrees on your unit circle. Then you're looking for cosine, and cosine is the first coordinate. So go here, look for 225. All right, that's right here. That comes down to here. The first coordinate is going to be this one right here, which is negative square root of 2 over 2. Letter B, tangent 5 pi over 6. So find 5 pi over 6. And tangent's the one that's on the outside no matter where you're at around the circle. All right, Olivia, what's that one? Okay, negative square root of 3 over 3. All right. Okay, so it's just a matter of finding them on the circle. Okay, So go ahead and find those three. Now, so talk a little bit more about reference angles. We basically did this on your paper, okay, on your unit circle. All right, this diagram here, you have it there. You just wrote it as coordinates. Okay. Now, in example 3, in listens closely, okay? It says use reference angles. Don't, okay? Just use your unit circle. Just, here it says find the exact value of sine, cosine, and tangent of 330 degrees. Right. Now, you could type those in your calculator, but you wouldn't get exact values. Okay? So you need to find the exact values, which are the values that are off your unit circle. So here, the big thing is, I want to make sure you write these correctly. When it says, if you want to do cosine first, because cosine is the first thing given, then that's up to you. Okay? But you have to write the angle down. Sine of 330 degrees. Cosine 330 degrees, what does it equal? Tangent of 330 degrees, what does it equal? Okay? And I just look at my unit circle, find 330. Sine's negative 1/2. Cosine's positive square root of 3 over 2. Tangent's negative square root of 3 over 3. See you later, Corey. Okay. So when it says use a reference angle to find the 3 of them, don't. Just use your unit circle. Okay, you got it. I want you to use it.